Hello, welcome to your chemistry class. How are you doing? I'm sure you are good. In our last class, we looked at carboxylic acids, which we made mention of the fact that carboxylic acid can also be called alkanoic acid or fatty acid. We actually looked at their nomenclature, how to name them, as well as their properties. In today's class, we are considering a particular carboxylic acid called ethanoic acid. And your presenter is E.B. Christian, BSc Honor, MSc, and PhD in view. As you can see on the screen here, CH3 in blue and then COOH in red. This compound is the molecular formula of carboxylic acid, particularly ethanoic acid. The COOH in red is their functional group. Now this one down is the structural formula of carboxylic acid. There are three hydrogen atoms attached to this carbon. So look at it how it's expressed here. Structural formula shows how the atoms are connected. Okay, then this oxygen here is now double bonding with this carbon, and then this oxygen is this other oxygen, this hydrogen is this hydrogen. So this is the structural formula of ethanoic acid, while this other one is the molecular formula of ethanoic acid. Now let's look at ethanoic acid. What does it mean? Ethanoic acid is an organic acid obtained from vinegar. It is the most common organic acid and the second strongest carboxylic acid in terms of acidic strength. It's important to note that methanoic acid is the strongest carboxylic acid. Now let's consider the laboratory preparation of ethanoic acid. There are various laboratory methods of preparing ethanoic acid, but in this class, we are considering its formation from complete oxidation of ethanol. Oxidation of ethanol with strong oxidizing agent like sodium heptazodichromate 6, sodium heptazodichromate 6 solution yields ethanol, which on further oxidation with the same solution produces the required ethanoic acid. The point we're establishing there is that ethanoic acid can be prepared in the laboratory in various forms, but for this class we are considering its preparation from oxidation reaction. So when you first of all oxidize it using this sodium heptazodichromate 7, it gives you first of all ethanol. Then further oxidation will give you the required ethanoic acid. Now look at this reaction. It helps us to explain better. We have CH3, CH2, and OH. This is ethanol. Now we have oxygen here in a bracketed square. This oxygen is from this strong oxidizing agent. The work of this oxidizing agent is to donate this oxygen to the ethanol, thereby oxidizing it. Addition of oxygen to a substance is oxidation. All right, so if you oxidize ethanol, you're going to have ethanol and water. The mechanism of the reaction is that two hydrogen atoms combine with this oxygen to give you water that is liberated. Then the CH3 is the CH3. The remaining C rather is this C. Then this H is this H, and then the oxygen here is this oxygen you see here, and that forms ethanol. Now the ethanol will further be oxidized using the same sodium heptazodichromate 7, being a very strong oxidizing agent. This is the formula in red for specification. Okay, so you easily notice it. That now gives you ethanoic acid. So further oxidation of ethanol gives you ethanoic acid. Let's look at the physical properties of ethanoic acid. Ethanoic acid has a sharp and pungent smell. It is a colorless liquid with a sour taste. Ethanoic acid without water is called glacial ethanoic acid, as it freezes at temperature below 17 degrees Celsius, forming ice-like crystal. It has a boiling point of 118 degrees Celsius. It is soluble in water and turns blue litmus red. Now let's consider its chemical properties. 1. Ethanoic acid reacts with alkalis to form sodium ethanoate in water only. Alkalis are soluble bases. Example is sodium hydroxide. So let's see how this reaction helps us to explain. Look at this reaction here. We have CH3COOH. This is ethanoic acid. When it combines with sodium hydroxide, it gives you sodium ethanoate in water. The mechanism of the reaction is such that when you break the bond between the hydrogen here and this oxygen in black, the hydrogen will be positively charged, while the oxygen will be negatively charged. Then if you break the bond between sodium and hydroxyl, the sodium will be positively charged, while the hydroxyl will be negatively charged. The next is for them to exchange their charges, following the basis of the reaction mechanism. Now, the sodium being positively charged is attached to this oxygen here, and that gives us CH3COONA, and that is sodium ethanoate. Then the hydroxyl that is negative will pick this hydrogen that is positive, and that leads to formation of water. So that is one chemical property of ethanoic acid. The second one is that it reacts with ethanol to form ethyl ethanoate and water only. Look at this. This is ethanoic acid and this is ethanol. So when ethanoic acid reacts with ethanol, it gives you ethyl ethanoate and water. The mechanism of the reaction is the same. You break the bond between the hydrogen and oxygen. You have oxygen as negative and hydrogen as positive. Now when you break the bond between CH2 and OH, the OH will be negative and CH2 will be positive. The next thing, you exchange their charges. So the CH2 will be attached to the oxygen here, and that leads to formation of CH3COOCH2CH3. Then the hydroxide that is negatively charged will be attached to this hydrogen that is positively charged, and that leads to formation of H2O, which is water. The third one, ethanoic acid reacts with phosphorus 5 chloride to form ethanoyl chloride. Look at the reaction here. CH3COOH is ethanoic acid. PCl5 is phosphorus 5 chloride. When the two react together, it gives you CH3COCl, which is ethanoyl chloride, and then hydrochloric acid, and this other component is given out. Okay, and lastly, it liberates carbon dioxide from trioxocarbonate 4 salt, particularly calcium trioxocarbonate 4 salt. What is the reaction here? You have two molecules of ethanoic acid, CH3COOH plus calcium trioxocarbonate 4, and that gives you calcium ethanoate. Water and carbon dioxide is liberated. So that is the chemical property of ethanoic acid. I'm sure you are blessed. Thanks for watching. See you in next class. Stay blessed, stay safe.